Hello children, this video is in continuity with the previous video since in this video you will be learning about the nuclear changes. As we did in our previous video that whenever radioactive emissions are there, either alpha or beta or gamma emissions are there. So in this video we will be discussing what happens to the daughter nucleus and the parent nucleus. What about atomic number and mass number? So this video is dedicated to the changes that occur during an emission. So let's start with. Here on the whiteboard, I have written an example where P is an element and X is depicting atomic number and A is depicting mass number. And if you check out on the left hand side, they have written that beta emission is there. So what about the atomic number and mass number of the daughter nucleus Q? Let's see. So it is just when you are going to balance the equations, these are just like the chemical equations and you have to be careful about the atomic number and mass number both on left hand side and right hand side. So if you check out here on left hand side, your atomic number is X and mass number A, as I told you. And on the right hand side, if you see here, it is -1. It means what should be added or subtracted from X so that I get the same number X here on the left hand side, right? So if you see here, this becomes X minus 1. What should be done? What treatment should be done to this to get X? If I'm going to plus 1 it will turn out to be X. Fine. So here answer will be X plus 1. And what about your mass number? It is 0. No change is there. It means the mass number as such as we were having in the reactant is going to be there on the right hand side, that is product as well. So the daughter nucleus has your mass number A and atomic number as X plus 1. So now let's discuss about another example. Now if you check out this second example, they have given you an element, uranium, where 238 represents mass number and 92 represents its atomic number. If you check on the right hand side, the daughter nucleus is thorium and with atomic number 90 and mass number 234. And this delta is representing large amount of energy. You are required to find out here which emission is it. Is it an alpha, beta or gamma emission? So let's see here. If you check out here, if you check out for your atomic number reduces by 2. If you check out the mass number reduces by 4. This is your atomic number and this is your mass number, right? And do we know which type of emission leads to loss in atomic number by 2 and mass number by 4? I think we represented in our previous example, if you remember, it was beta emission. So beta was represented like this. Gamma emission is only emission when there is going to be nucleus in the excited state and large amount of energy is released in the form of gamma radiations or rays, right? So in gamma emissions, no change in atomic number or mass number is there, right? But here we have. So beta, not an option. Gamma, again not an option. Which option is left now? It is alpha. And as such also, we know that alpha emission is doubly ionized helium, right? So it is doubly ionized helium. Fine. So don't you think so? It is representing an alpha emission, right? So I can write here, this is going to be helium 2 and 4. Okay. So I'll quote another example. Here if you check out, only one step is there. But now I'll be quoting an example where they are showing you multiple steps. So let's see how to proceed with those multiple steps. Okay, so let's see for the third example. Now, if we check for this third example, they have given you multiple steps, right? Here they have shown you an element X with atomic number Z and mass number A. This is depicting alpha emission, gamma emission and beta emission. And the only thing is here two particles, twice emission of beta is there, right? So how to find out what is going to be the atomic number of X, X1, X2 and X3? Let's see. So if it is an alpha emission, as I know alpha is going to be this, right? It means atomic number is going to be reduced by 2 and mass number is going to be reduced by 4. So what I'll be getting? Z minus 2 and A minus 4, right? Now it is your gamma emission. So gamma emission itself tells me that this must be an excited state, right? So this star is actually telling you that it is in excited state, right? This is in excited state, right? So it means there is not going to be any change in your atomic number and mass number. Next is your beta emission, but that beta emission is twice. It means 2 times it happens. That's why it has been written here 2 beta. I know if it is going to happen for once, it's going to be this much, right? If it's going to happen 2 times, if it's going to be 2 times, it means it's going to be beta minus 2, 0. It means now the atomic number is going to be, is it going to reduce? No, it is not going to reduce because it is minus 2. It means I have to add something to it to have the same on right hand side and left hand side. Fine. So I think I can show it to you here. If it is your X, Z minus 2, A minus 4 and it's going to be 2 times beta and it's going to be X3. It means if I want to, this represents Z, right? This is Z and this is 2. So if you see here, this is representing Z minus 2. Now what should be there here? Okay, so that I have the same as there on the left hand side. And I know I have this thing here because it's 2 beta, right? So it means I need to, this is Z minus 2. It means I need to add or subtract. What it's going to be? It's going to be only Z. Only Z. That's why this will become Z minus 2. This and this Z minus 2. And here also we have Z minus 2. And what about A minus 4? It will remain A minus 4. Right? So I hope so. You have understood this example, how we calculate. But the only thing is you can show or you can proceed with the numerical in different steps. But at the end, you must show that what is the final atomic number and mass number. So I hope so you have followed how we proceeded with this step-by-step emissions, right? So last example I would like to quote you, where they are actually giving you an emission where they are actually asking you to find out for atomic number and mass number of a reactant, not of the product. They have given you for product, but you have to find out for the reactant. So let's see that example also. So this is the example. Now the only thing is, if you see here, they have not given you atomic number and mass number of reactant, but of the product, right? So how to proceed with? The only thing is, now instead of arrow moving this, we are going to find out like this. Okay, so I'll be now writing all the things in opposite way, and arrow is going to be opposite. So it is 69,172. Now if alpha emission would not have happened, then the atomic number it would not have reduced by 2 and mass number would not have reduced by 4, right? If next is your again alpha, this was alpha, right? This is your X1. Again, if alpha emission would not have happened, the atomic number would not have reduced by 2 and mass number would not have reduced by 4. Now, what is left? I'm left with X and it's a beta particle. Now, if beta emission would not have happened, right? It would not have happened. The mass number is going to be, what the mass number going to be? It is, first of all, mass number is going to be same. And what about your atomic number? This is going to be, because it's -1, right? So this will become 72. Is it so? So let's see whether we have done it correctly. 71, 73, right, and I think so we have done it correctly. The only thing is now, the arrow, like we are showing it here, it was x2, x1 to, but here I'm showing it in other way, right? Now you can write all the answers there, right? So x will be, must be this. X1 must be 73, 180. X2 must be 71, 176. So don't you think so it becomes so easy if I just start with a product instead of reactant? Fine. So these are few examples, and I would love you people to try more examples, because such type of questions we usually get in exams for maybe 2 or 3 marks, right? That depends upon how long the chain they are going to give you, right? So with the hope that you have understood about radioactivity, about nuclear changes, right? I bid bye to all of you with the hope that you will be geared up for the next video. So in my next video, I'll be starting with the new chapter. Till then, God bless you. Take care all of you. Stay safe and stay healthy. Bye-bye.